Good afternoon. Today we are going to learn about streams and file I/O. Very important. The material in the lecture slides is very similar to the material in the book, which is different than how I'm going to cover it this quarter. Okay? So there is a principle of memory management called RAII, Resource Acquisition as Initialization. But there is a general consensus over how memory should be managed, and in particular how a resource like a file or like heap memory should be managed by a program. Okay? But before we get to that, let me first go back to the code involving point2D, color point2D, and polymorphism. This is not in chapter whatever of your book. This is actually a topic in more chapter 15 of your book, of what I'm going to go over right now. And that's the idea of the following. Remember that we started out with this idea of, okay, you have a point2D class, you have a color point2D class which inherits from the point2D class. So it gets all the properties, and it can add its own properties. Okay. Now, we said we can create a point2D object by slicing away the extra properties that color point2D has. And then as long as we're working with objects, every object knows exactly what type of class it came from, or what type of object it is. Okay? And if you tell it to call the print function, and it's a color point2D object, and it has a print function in its own class, it will call that print function. Now, if it doesn't have a print function, what will the color point2D function look to next? The base class, the point2D class, exactly. And if the point2D class has a print function, it is more than able to invoke the point2D print function. Okay? Then we went in the opposite direction, right? So rather than saying, oh, I have a color point2D object, and I want to create a point2D object by slicing away certain parameters, we did a reversal. What we said was, oh, wait a minute. We have a collection of points whose key property is merely the x and y values. Some of these points have an extra color property. Some of them do not. Maybe some of them have an extra property called weight, which is a double value, okay, as in the homework. Okay? The key thing here is that we can point, in principle, to any object or location in memory, for the most part, that we want. Any variable we can point to. Each address in memory takes up the exact same space. So a pointer type takes up the exact same amount of memory. But there's the logical error which says, for example, you cannot have an int pointer point to a double variable. Okay? In principle, there's no issue, because you can point to the address of a double variable. I mean, you can contain the address of a double variable. There's nothing inherently, size restricting about the address of a double, but logically speaking, that int pointer cannot interpret the double in the way that it was meant to be interpreted. But a base class pointer, this point2D pointer, knows all about the properties of the point2D class, and so any object from a class that inherits from point2D also has these properties, and so in principle, there's no restriction on whether or not you can contain the address of a color point2D object. The question becomes, should you be allowed? Should point2D pointer be allowed to point to an object which is not of type point2D, but which actually does contain all of the point2D properties? And the answer that we saw was in C++, yes. As long as the object, as long as the class color point2D inherits from point2D, we can point to an object of that type. Not only can we point to it, but we don't lose any information by pointing to it. When you slice, that P3 variable loses information. It has no idea where it came from, or that it came from a point2D with a color property. But this point2D pointer can either be ignorant of the actual type of object that it points to, Or what keyword did we introduce last time, which lets it determine at runtime what object that it is pointing to? Virtual, right? Adding in virtual basically gives the pointer the ability to create a lookup table, and then when we try to call a function like print, if the keyword virtual is in front of print in which class? Base class declaration, then it will actually check to see, am I pointing to a point2D object or a color point2D object or what type of object? And then it will try and call the print function as if that object was calling the print function itself. In other words, if it has its own print function, it'll call that one. And if it doesn't, it'll go down the line trying to figure out what would have been called otherwise. Okay? So we need virtual in order for that to be invoked. Okay. Now, there is a subtle issue with memory management here. And maybe I should wait. Nah, I'm going to include it because this is important to have in your mind when you're doing the homework. Okay, so when you're doing the homework, you're going to create a bunch of points on the heap, and then you're going to delete them at the end. Okay. Now, there's something very important that happens when you're dealing with polymorphism and heap memory. Okay. So let me create a couple of points on the heap, and I'll just to demonstrate this principle. Okay, so let's get rid of all this stuff here. Okay, so like I showed you guys in the code, equals new point2D. Uh-oh, what'd I do? I did something. Come back. Okay, point2D, 1, 2. New, say, color point2D. We just say like blue, 42. Like that, okay. And then let's create another one. 3, 4, and let's create one more of type color point 2D. In fact, let's keep the color point 2Ds together. Okay, and this will be red. Something like that. Okay. How many students learned about something called a destructor in 10A? Just a few. I usually don't cover destructors in 10A because I don't emphasize heap memory in 10A. Okay? You really need a destructor when you're working with heap memory. Okay? And we're going to actually work with that this quarter. So I do want to introduce this concept to you now, sooner rather than later. So what is a destructor? Let me ask you a question. What is a constructor? A constructor is a set of code that gets run when an object is created. Now, would it surprise you if I said you're capable of defining a set of code that will run when the object is deallocated, okay, or destroyed? There's a subtle difference, but just when the variable no longer exists, and it's a class object, you can tell that class object that just like you ran a set of code when you were created, you can also run a set of code when you're destroyed. Okay? So that's what's called the destructor, and this is how it works. So the reason why I don't teach it in 10A is because its use is very trivial for what I teach. So it's denoted by, and I kid you not, this is the actual syntax, tilde point2D. Okay? That's what it is. Typically, it does nothing. Okay? Unless your class object manages heap memory itself, it does nothing. Usually. Okay? For the most part. double x, double y. Those are variables that are going to be created locally. So if the variable point2d is created on the stack, they get taken care of on the stack. In other words, wherever point2d object gets declared, those variables x and y are going to clean up after themselves because there's no news anywhere. Okay? Question? Okay. So unless you're manually managing heap memory inside of a class, the destructor doesn't really do anything. But it does get called, and here's what I mean by that. So let me make this not be trivial. Let me actually show you how to define, just to demonstrate exactly what happens. So we do it exactly the same as if it was a constructor. Okay? It takes no parameters. You don't actually call this function. Okay? Let me repeat that. You don't actually call this function. It gets called automatically. Let me just call print was just deleted. Well, I'll just say destroyed. Now, watch this. That was odd. Oh, no, that's not odd. Duh. Okay. I mean, yeah, well, here's why. Okay, watch this. Let me create a point2d object, p, 1, 2. Okay. All right, so I created the point p, and at some point, that variable p got taken care of. Okay? The memory, whatever the contents in memory were, they got reclaimed by the processor. I don't have to worry about it. It's not a memory leak. Okay? Now, what happens when I create a point or a set of points on the heap without calling delete? What happens? Well, none of them actually call their destructors. So what happens is that memory actually sticks around until your application ends. That's not a good thing. Especially if you create these points in a loop, and that loop runs 1,000,000 times, and you just want to create a point and destroy it later. Okay? Again, you're accumulating a set of memory, you're reserving a bunch of memory, but you're never actually releasing it until the end of the program. Okay? So, remember new and delete? Well, when you call delete, okay, now delete will invoke the destructor for the object point2d that it's called on. Okay? So let's do that with all of them. So let's delete ptr2, delete ptr3, and delete ptr4. Okay, so a couple things to point out. One is they get deleted in the order of deletion. Well, okay. Deleted in the order of the lines of code. What gets deleted last? No, which point gets deleted last? P, right? The one that was created on the stack. And the reason is because when you call delete, that call to delete invokes the destructor. But if your object lies on the stack, it automatically gets called when the variable it's called goes out of scope. Okay? So when main ends, and variables like int and double that are local to main, when main ends, right, all those variables you were told get reclaimed by the processor, and you don't have to worry about managing memory. But just as we saw here, okay, point P, that gets automatically reclaimed at the end. But any variable that we create on the heap has to be deleted equally as manually as it was created. Okay? Otherwise, it will not get reclaimed by the processor until the very end of the application. Yeah.
When you have a for loop or like some other like curly brackets, is each one of those structures get its own stack? Like if you create a for loop in the main, would that for loop itself have a separate stack within the main?
So the question is, if you create a separate for loop inside of main, will that create its own set of kind of separate stack with its own variables? Yeah, in fact, you can do the following. Check this out. I don't know if you guys know you could do this. I've just created a local stack. Those pointers that I've created only exist inside those brackets. I don't even need a for loop. Okay? It's about the brackets. If you define a variable inside of a set of braces or curly brackets, it's local to that set of curly brackets. Okay? That's why when you call like a for loop and you define a variable inside the for loop, it doesn't exist outside. It's because the scope, the term is called scope. It's in your book, but it's in a later chapter. So here, without even any for loop or anything, what I've said is I want these variables to be local to just that block, and as a result, they don't exist these names don't exist outside that block. And in fact, I can create a point2d point called q, like so. And, well, let me do something. Let me put the deletes inside the brackets. But what you'll see is that Q is going to get deleted first. Let me put Q in its own bracket. Okay? So that's kind of the point is Q, P gets created. Then Q gets created inside the brackets. At the end of the brackets, it no longer has any meaning. So it gets reclaimed by the processor. So its destructor gets called. Then I create the new points, whatever, and then it destroys them, or actually it deallocates them. That is the term for that, in the order in which you call delete. And then finally, P at the very end gets automatically reclaimed by the processor. Okay? So yeah, basically there's a concept called the lifetime of a variable, and it's all of these concepts are connected, and sometimes it's actually challenging to figure out what to tell you at what time, because otherwise we could spend all of our time being bogged down by these like little things about, oh, what about the lifetime of a global variable or this type of variable or things like that. Okay, so yeah, there is a nice depth of understanding there that you don't fully need right now, but we eventually get there in 10C. The question is, should we always have a destructor? That's what we're getting to right now. Okay, so this is now very important. Did we define the color point 2D destructor? No. So which destructor actually got called? The base class destructor. Does the base class constructor, is it aware of the color property? No. It's only aware of its own class members. So what happened to that string property in the color point to the objects on the heap? Leak. Leak. Okay. Did it tell you there was a leak? No. Did it compile? Yeah. Did it run? Yeah. Would you know that there's anything wrong with doing it this way? No, but there's a leak. That's why people hate C++, okay? Because you can do things like this that don't cause any errors, any warnings. There's no way you would possibly know that it does cause a leak unless you just kind of knew it. Okay? Sort of like a language. Like in English, sometimes you look at the spelling of a word and you're just like, how did you know to spell it that way? And you're like, I don't know, I just saw it spelled that way before. Eventually you get the hang of it, though. There is a logic behind it. It's more than that. Okay? But yeah, this is where it gets a little tricky. Is memory management is horrible, and this is why you typically don't want to deal with news and deletes on your own. And this is what I'm going to try and shelter you from for the remainder of the quarter. I want you to understand it so you can control it, and then utilize the standard tools, that don't force you to utilize these ideas. Okay? So this is really tricky, and if you don't get it perfect, it's really bad. Okay? So let's do our best to understand it, and then the silver lining is you don't have to do it manually yourself all the time. Most of the time, you remember the vector class? There's other classes that are built in that you can use which handle all of this for you. Okay? So with that in mind, here comes the question. I probably want to call the color point2D destructor. How could I get it to invoke the color point2D destructor? Virtual. So there is a paradigm, there is a rule of thumb that you learn in programming, and this is like an interview question as well, which is how do you prevent memory from the inherited class from not being leaked when using polymorphism? And the answer is you make all your destructors virtual. That's kind of the rule of thumb. You make all your destructors virtual. Okay? Now, what is it going to print out? So one answer is only the point2D. Anybody else have another one? Well, let's see. Did I lie to you? Am I a liar? Okay. Now, what if I told you, right? So it basically printed the same thing. But it just told you putting virtual means that it calls the derived class destructor. How am I not a liar? Okay, the answer is something along the lines of the pointer still contains the information. Okay. I'm looking for something a little more just concrete, more simpler. Did I define a color point2D destructor specific for that class? The answer is no. So by default, what do you suppose? What would be a logical behavior for an inherited class destructor to do? Call the base class destructor. Okay. So how would I prove that I am actually invoking the inherited class destructor, which also calls the base class destructor? Let's define explicitly the inherited class destructor and have it print out a message demonstrating that that's in fact what we did. So we go to our color point2D. Remember, tilde, and you have to give it the same name of the class, just like a constructor. Remember, did I ever call tilde color point2D anywhere or tilde point2D anywhere? No. You're never going to do that. You're never going to do that. Don't ever try and call the destructor. It gets called automatically. Yeah. What happens if you do call the destructor? Your computer may explode. No, I'm not sure if that's allowed to happen. There are certain things where if you try to do them, your computer is allowed to explode. It's kind of a joke, but it's like it's so undefined that you can't really specify. I don't recommend it. You can try and see what happens, but I honestly don't know. I never tried to do. We could try it if you want. I mean, it's not taboo or anything. You can try these things. I just never thought to experiment with it. Actually, I did experiment it once, and then I quickly realized my error, which was, wait a minute, you're never supposed to call this, and I realized my mistake. So, but I'm not even sure how you would call it. We can think about that a little bit later. Okay, p.print, or not print, just print. And then we'll see out, what did I do for, this. Print was just this. Okay. Oh, and I'm just going to put in parentheses color, just so that we can tell which when the cout statement was called when. Okay, now let's see what happens. Ha ha ha, there we go. Okay. So let's go back up to the main. All right, let's now take a look at all of our points. So first one is Q. That one is the first one to be destroyed. It wasn't created first, but because it was locally created and then went out of scope, it called its destructor sooner rather than later. Then we called the destructor on the point 2D 1.2, point 2D 3.4. And then when we call the destructor on putter 3, PTR 3, then what it says is it prints out the blue 4216, and then it says was just destroyed. That came from the color point 2D destructor. And then the color point 2D destructor did what? Automatically, it called the, someone said it earlier, the base class destructor. In other words, what it does is it says, okay, I will take care of cleaning up after just the variables that I have defined locally in my class. And then I will call any and all base class destructors so that each one of them presumably has ways of cleaning up after itself. That way, everything you do is local reasoning. You only have to worry about the class that you're working on. And if your class manages heap memory, you manage it in your destructor. If the base class manages heap memory, it's supposed to manage it in its base class destructor. Okay? So that's the idea, and we get the repeated in point 2D4. Okay. So we go back up to let me just go back up to the top. I think this is lecture 9. I'll update these at some point. Lecture 9. Make all destructors virtual. If you ever get asked an interview question and you don't know the answer, just try saying that. It might say, I don't know. Okay, so that's kind of an out-of-the-box thing. Yeah. Why do we need a destructor if we're calling delete? The answer is you don't need a destructor unless you're managing what type of memory? Heap memory, exactly. Okay. So do we need it for our point 2D or color point 2D? Oh, okay. Let me rephrase that. You don't need to define instructions inside of the destructor. But if you're going to use a class as a base class and use polymorphism, then what do you need out of that base class destructor? You just need it to be virtual. Okay? It doesn't do anything except indicate that when you go to get rid of all the memory, you need to look to the most, you have to figure out what type of object you are first, and then start the chain reaction of destructors at the top level rather than the bottom level. So like I said, calling print and then seeing out, I just destroyed this point, that you don't need that. But you do need to declare the base class destructor virtual. That's all you need to do.
Did simply including the destructor for the color point 2D class fix the problem that you have the color like persisting after the object has been deleted, or just like you have to do like delete the string? Like how does that work?
So the question is do we need to call delete on the string object or things like that? And the answer is no. Don't do any of this. No. Strings, remember string, vector, heap, stack, what did I say? You haven't used new with vector or string before. Don't start doing it now. Okay? You only use new and delete when you're managing heap memory yourself. Everything else gets automatically reclaimed by the processor. Okay? So unless you consciously make the choice to write new somewhere, you don't write delete. You don't need to manually clean up after anything. Yeah.
So if I just have like an empty destructor like in my class and I have like string and vectors or anything, as long as the empty one is there, it will be taken care of for me?
Yeah, and you make it virtual. You make the empty destructor virtual. Yeah, as long as you only have fundamental types, vectors, strings, anything from the standard library that automatically handles memory management for you, yes.
Just to be clear, so if I didn't have that empty one, even those fundamental types would leave because you wouldn't know about them like in the base class, for example. If I didn't define one.
Okay, if you don't make your base class destructor virtual, then this is not about heap or stack. Any variables in inherited classes will not get the memo that they need to be freed up from memory. Stack, heap, standard library, doesn't matter. Any and all variables in any inherited class. If, on the other hand, you do put in virtual, then you rely on each class itself, the vector class, the string class, whatever variables. Each internally, locally, will take care of cleaning up after itself. Okay? So again, make all destructors virtual, make them explicit, make them virtual. Not keyword explicit, but make them, write them out, and then put virtual in front when you're dealing with polymorphism. In other words, if you're making a class that could ever be potentially used as a base class for another class, what should you do to the destructor? Make it virtual. Okay? Otherwise, let's say somebody tries to use your class, right, and they don't have access to your actual class. You've hidden it from them, you've protected it from them. Now all of a sudden they have an automatic memory leak if they try and do any inheritance. Okay? You might not want them to inherit from it, but there are other things that you would do in that event. Okay. Does that make sense? Yeah, question.
So if you use delete, you have to have a destructor defined, right?
No. So the question is, if you call delete, you have to have the destructor defined. You have to have a destructor defined, but it can be automatically generated by the compiler. Because up to this moment, many of you didn't even know what a destructor was, right? It just magically worked. A destructor has to be defined, but that's not the issue. You will get one defined. The question is, does it need to be manually created by the programmer? The answer is no. Anyone that gets automatically created either by the compiler or by you writing code will get called. So even if you don't supply one, it's not that your class doesn't have a destructor. It's just that it doesn't have any specialized behavior.
Okay, so it's just when you make it a more complex situation, you have to explain how to destruct.
Exactly. When you define it explicitly, you're giving them explicit instructions for what else to do other than just give the memory back. Okay. What do I want to talk about now? Okay, then let me talk about, all right, I said I may have lied about file I/O. Memory management is a little bit more important. Once we understand memory management fully, the file I/O stuff, the way that I'm going to be presenting it, is going to make a bit more sense. And this is the more modern way of presenting file I/O in C++. So let me now ask a very important question, which is, how would you store a collection of points on a plane? A class with an internal variable called like a vector of 0.2ds or something, right? But instead of 0.2ds, instead of a vector of 0.2ds, now that you know polymorphism, what might you make a vector of? 0.2d pointers, right? And then you can have a collection of any type of object that derives from the base class, 0.2d class. Okay? So that's what we're going to do, and I'm going to tell you very specifically why we would do it this way. Is there a question? Say that one more time. Oh, okay. Okay, sure. I think I know what you're saying, but let me hold off on that as well. Okay, so keeping track of new and delete is really annoying and foolhardy and leaves room for a lot of potential errors. You might forget to delete. You might try to delete twice. Memory leaks abound. Okay? There is a principle called, and this is not in your book, RAII. Resource acquisition is initialization. What it basically means is, and this is how in 10C, when I introduced the programming language called Qt, which is like a GUI-based graphical user interface, but using C++ syntax, this is the memory model that they basically use, which is you're going to store a collection of objects, and your class, or what you're going to actually store is a collection of pointers to heap elements. Okay? So we're going to create a collection of point2D pointers, and each pointer is going to point to a object that lies on the heap. And then because it's a class variable, when that class variable goes out of existence, we want to call delete on all of those objects. Okay? So here's what I mean by that. What I mean is the following. What I mean is I want to create a class called, I don't know, points on a plane. Is that a chuckler? Does anyone get where I got this? Points on a plane. Yeah, snakes on a plane. Okay, yeah, all right. Have you guys seen that, or is that old? Is that so old news now that no? Okay, never mind. Anyway, okay. So the idea behind points on a plane is going to be the following: we are going to store a vector of point2D pointers. Why might we do this? We store the pointers because we may want to invoke polymorphism, and that way we can store a collection of these points. Now, why are we building a class to do this? Okay. The answer is we want the class object to handle all of the memory management for us. Okay? That's the answer. In other words, we want this class to handle all heap, memory, news, and deletes. Okay? We don't even want to think about memory management. Right? When you create a vector of ints and you do v.pushback of 5, are you thinking about where that 5 is being stored? Are you thinking about how that vector or that value of 5 is being referenced or pointed at or any of that? No. You want to be in this nice, safe little world where you add a value like 5, and it magically goes in there, and you can reference it by doing v of 0, and it gives you the 5. And you don't want to have to worry about all the details. And when that vector goes out of existence, you want to make sure that that 5 that you inserted gets reclaimed by the processor and doesn't cause any leaks. This is basically how it's done. This is the simplified version of how it's done. So what we do is we create, let's say, a constructor, points on a plane. By default, let's just say it does, well, what would it do by default? Yeah, empty vector. But in other words, it would pretty much just do nothing, right? When you think about it. Because by default, what happens to a vector of anything by default? Vector of size 0, right? So it has nothing. It has potential for things, like many of you. Okay, but it starts out as size 0. That was a stupid joke. Okay, I admit that one. All right, so we're going to want to create like a pushback function, right? So let's create a function called add point2D. Or maybe just add point. And here's why. Okay? Double x, double y. Now, can I create another add point class and maybe double x, double y, and what else? Maybe string color? Okay. So the idea is what will these, make them void, what will these functions do? Yeah, they'll add either point2D pointer to this vector, and we're going to create the object, and where is that object going to lie? Heap. Yeah, exactly. Good, very good. Okay, so excellent. Okay, so we're going to let the class create the object internally, and because we've created the object internally, we get to do what internally at the end? delete. Okay? That way, anybody that wants to use our points on a plane class, do they have to think about point2D objects and news and deleting and heap memory? No. Okay? They get to just focus on adding a point, adding a color point, adding a whatever point. I definitely forgot a semicolon. I always forget the semicolon at the end of classes. I don't know why I do this. Do you know why you need a semicolon at the end of the class? This is an actual interview question. Do you know why you need the semicolon at the end of the class? Because I can create an object of that class right there. What? Okay. Don't worry about it. But that's the answer. Okay. That's why you need the semicolon. Okay. What you're doing is don't worry about it. Okay. But that's why you need the semicolon, because you can do weird stuff like that, and then you can do things like. I mean, object exists. It's a variable that is of type points on a plane class. Okay. Technically, I think it has file scope, which is it makes it like a global variable. Kind of neat, huh? Yeah. But don't do it. Okay. Don't make global variables. But that's why that's there you go. Don't say I didn't teach you anything useful. All right. Here we go. Let's define these guys down below. I think I'll show you guys how to do separate file compilation next time. This memory management stuff I think is uber important. Okay, add point. Now, this is a points on a plane member function. Points on a plane. Okay, now, what I want to do is I want to take points and I want to do dot what? What is points? What type of object? A vector. So I want to do what to it? Push back. What do I want to push back? Be careful. Yeah, I want to push back the address of a point2D object that lies on the... Okay, he beat you to it. Come on. That was your time to shine. Okay, yeah. The address of an object that lies on the heap. How do we get the address of an object that lies on the heap? It's the return value of the new operator. And we're going to create the point2D using what values? X and Y. How about here? Same thing, right? Except we do a color point2D. And here I did the constructor a little weird. Let me be consistent with my color point2D class. Color X, Y. So now it's telling me it doesn't match the variables that I put in the class. This is correct, because I need to switch this order. Okay. Now, if I want to do, points on a plane, say P dot add point 1, 2, P dot add point blue 42, 16. Okay. Let me run this. Now, what do we know about point2D objects when they get reclaimed by the processor? What do they call? They're destructor. What do I currently have the destructor set up to do? Yeah, I have it set up to print out a message saying that you've been reclaimed. Did any of those appear? No. What it means is, okay, this is important. What it means is the points on a plane object P gets reclaimed by the processor. But just because each of the pointers gets reclaimed, What about the memory on the heap that they point to? What happens to that? Still there. It's still there until the end of the entire program, but yes, it is still there, and it is a memory leak. How do we fix it? Create a points on a plane destructor. You see, in the point2D destructor, the color points2D destructor, do you need to have any instructional code in those destructors? No, you just need to make the base class destructor virtual, and that's it. But for this class, points on a plane, do you need a destructor? Yes. This necessitates introducing the idea of a destructor. Rather than introducing it as this cool thing that runs after a variable kind of goes away, gets reclaimed by the processor, I'm telling you, here is the need. Here's an example that necessitates having a structure like this. Okay? So let's put that in there. And let's define it. Oops, I'm going to need some colons there. Okay. Now, how do I delete, again, points is my vector. How do I tell points to basically let the processor reclaim all of the heap memory points that it is pointing to? Yeah, in the back. Yeah, so I just called delete on what? On every element in the vector, right? For each pointer in the vector, I get to call delete. Not only do I get to call delete, I must call delete. Now, is anybody else aware of those objects? No, everything was kept internally, right? We passed in values by which we constructed those points, but only the points on a plane class object is aware of those locations, and only it has the authority to delete them. Okay, so how do you loop through all of the elements in a vector and call delete on each element? For loop. So there's different ways to do it, right? You can do for size t, I equals 0, comma, right, n equals points dot size, I less than n, I plus plus. I can do points of I with the delete in front. That will work, right? Or what else could I do? Yeah.
Well, if you run the loop, you have to separate the I because it's only equals the size right?
Very good question. Let me just hold off on 1 sec on that. This works, right? It works. So the question was, don't you have to worry about the size of the container and it's going to get rid of the... This is the beauty of it. The beauty of it is, am I changing the size of the points variable at any time in this process? Do I need to pop back any of the pointers in the points vector? No, because you know this, right? You can create a vector of size 50 million, and what happens at the end of when the variable goes out of the scope? It gets automatically reclaimed. So there's no reason to call popback because the vector class itself is set up to handle that type of thing at the end. Okay? So in that respect, we just call delete on each of the points. Yeah? Oh, very good question. Don't you put the brackets in front of the delete and before the points? That's if you're deleting what? An array. is a vector in array. Well, okay, from a intuition, like syntax, not syntax, but verbal English language point of view. Okay, yeah, it's the idea of an array. But as a C++ data type, a vector is a class object, and an array is a different type. So no, you don't. But what you do have to do is make sure you access the ith pointer and delete the ith pointer for I equals 0, 2, and -1. Okay. Now, what's a C++ 11 way to write that statement? Yeah, the range-based for loop, the auto. For, auto, and then I don't know if you should do auto reference or not. Did I do auto reference or just auto last time? Just auto, just keep it at auto. It's just a pointer. It's going to make a copy of a pointer type, which is fine. Pointer types don't take up that much memory. Points, delete, x. Okay? Very simple. You can even put it all on the same line if you want. I don't recommend that. But OK. So that's an example of where we need the destructor. It's because we are manually managing heap memory. OK, see you on Friday.